Tonight will be our first sessions in the 我们有 consecutive 3 nights for advanced topic debate. 那第一个是 cutting edge question is alien world colonization. 那我们今天晚上的 the person who will give you a short introduction is Professor Karen Meech. Let's welcome Karen.
Well, thank you very much for inviting me. Now, since I don't speak Chinese, this will be in English. And feel free to raise your hand if you're completely lost, and I can slow down. So let's start with a little background on colonizing Mars. And what I thought I would talk about tonight is very briefly why it would be Mars as opposed to something else. I want to show you a few mission results about Mars so you get a feeling of what Mars is like. And then we'll talk a little bit about what's required for colonization, and then at the very end talk about some important issues. So let's start with why you might colonize. And this applies not only to Mars, but to anything. And if we look historically, why people have colonized, on the positive side, it was just purely for trade, economics. This is the roots of Marco Polo. This is the Hawaiian Polynesians. The Polynesians discovered Hawaii. They were just exploring new worlds. We have a rich science fiction heritage where people wanted to go out into space. And of course, there was the American pioneers that went west, both for land and economic purposes. But we also have reasons that you might think of for colonizing Mars that are on the bad side. Perhaps we have destroyed Earth in many ways, either from atomic war, maybe global warming. Many of you may recognize this image. This is not Beijing. This is actually from a science fiction movie called Logan's Run. This is supposed to be Los Angeles of the future with terrible pollution. And of course, we have problems with overpopulation and potentially other problems that would lead us to want to colonize another world. So some of the things you might think about for colonization is how much will it cost? You have to weigh this against the reasons for going. Why Mars? Well, it's the nearest planet. It's got valuable resources we might use for colonization, and it has the potential for us to inhabit it. May have had the potential for life early on. So it really is the best place that we can think of for colonizing in our solar system. So to start out with a little background, I know most of you have backgrounds in biology. I want to show you what early Mars was like to set the stage for conditions today and the role that we'll play with colonization. And we'll do this in the context of early Earth. So this is the timeline, the present going 4.5 billion years ago. This is what Earth was like as it was first forming, a very hot surface. Oceans formed fairly quickly. And just about as soon as it could, life began on Earth. At about 3.8 billion years, we've got fossil evidence of life. And then, of course, as time marched on, life eventually became fairly sophisticated. Here's what happened during the same time on Mars. The earliest period, we know there was liquid water on the surface of Mars. We see evidence of lakes. We see evidence of river systems. What's controversial is whether it was warm and wet or cold and wet, but there was clearly water. And since then, we've had lots of evidence of volcanoes, a little bit of evidence of water, but today the water is all in the form of ice. And we certainly saw evidence of volcanoes up until fairly recently, lots of lava tubes on the surface of Mars. So what makes a world good for colonization? Why does it become habitable? Well, habitability really means, can life survive there? So from the point of view of early life or potential microorganisms on Mars, it really means you need some atmosphere. You really want liquid water because life needs water. You'd like organics for food, and you need some source of energy. But in terms of us surviving on Mars, you also need useful resources. So these are some things to think about. Now, what's the evidence for past Mars habitability? I've talked about it a little bit. We see plenty of evidence that there has been water on Mars. And I'm going to go through some mission details to show you how we learned about this. We also see some very interesting minerals, some very interesting rocks on the surface of Mars that tell us about how much water there was in the past. Some of these on Earth, clay minerals, were probably important for early life on Earth. So again, these are the sorts of evidence that we'll look for on Mars as to whether or not it has been habitable. So I want to go through a few slides that just shows you some of the highlights from some of the missions that have gone to Mars. And what you should be listening for is not all the details of the missions, but what's the big picture that the missions have taught us about Mars. And so I'll start with this map. Here's a global map of Mars. You see the north and south polar caps where we have obvious ice today. The yellow labels are where we have definitely gone to Mars. The white ones here were potential mission sites, but in fact, the mission, the most recent one that's still active, went to this crater here. So you can see we've sampled a lot of Mars. So the earliest one, the US missions that landed were the Viking, twin Viking missions, Viking 1 and Viking 2, and their main goal was to search for life. And the way they did this, they scooped up some soil, they put water on the soil, they gave it nutrients that microorganisms would like on Earth, and they waited to see if there was any product of metabolism. No evidence for life at all. The question is, would Mars life eat the same thing that we like? So while there was no evidence, they learned a lot about Mars. They learned about the atmospheric conditions, the temperature, and in fact what we found out that was the atmosphere is mostly made of carbon dioxide, very little nitrogen, no free oxygen, and there's very little atmosphere, less than 1% of what we have on Earth. And that'll be important to think about for colonies. Here's some images from those early missions, the Viking mission. It just, everywhere you look, it looks like a barren desert full of rocks. All right, move on to the next mission, the Mars Pathfinder. This shows where the Pathfinder landed. This mission was more to demonstrate that we could get there, to look at the technology for landing a bigger instrument. But the Pathfinder could actually roam around and come up and examine some of these rocks. Many missions pick very boring spots to land because it's safe. And so this mission picked a very smooth area near some river channels because they hoped there would be a variety of rocks. And so again, they found evidence that water had shaped the geology of early Mars. Now the next mission was the Mars Global Surveyor mission, a United States mission. This one gave us some really exciting evidence about water on Mars, and I'll give you a few highlights. These maps here show some maps that were made by shining lasers down to the surface, bouncing them off, getting detailed heights of surface features. And it may surprise you that they knew the altitudes of features on Mars better than they knew Earth at that time. And what they found was that the entire northern hemisphere seems very smooth, and it was very depressed, as if there had once been a Martian ocean. They also found evidence of water. This is a false color map showing near the equator some minerals that usually form, that precipitate out of water. So this again was evidence of long periods of liquid water on Mars's past. And to everyone's surprise, they saw gullies that looked like recent water. And recent in terms of NASA could have been yesterday, or it could have been 100,000 years, but it turned out that in the 10 years that this was flying, this was really recent. New gullies were forming. The next mission, the Mars Odyssey mission, was not a lander. This one was a orbiter. But again, more and more evidence of water. We could see evidence of surface ice just beneath the dusty layer on Mars. This is an impact crater, and you can see underneath it's white, and that indicates there's ice just beneath the surface. So while today we definitely don't have liquid water on Mars, there's plenty of water, but it's in the form of ice beneath the surface. There were also some spectacular images. What this is looking at is the North Pole up at high latitudes, and we're looking at layers in the North Pole, and they could tell that these layers are dust mixed with ice. So there's a substantial amount of water today on Mars. This mission also had some new technology that mapped the entire surface and could start to study the minerals, the distribution of minerals, and they made many false color maps. This is a big impact crater called Gale Crater, which is the site of the most recent mission, and the different colors show different minerals, and so they can learn about the history of the geology of the region on Mars. Moving forward, the next mission, the Mars Exploration Rovers, these are still ongoing. There were 2 rovers that landed in different spots, and these had mobility and could explore large regions on Mars. One of them has sadly died, but the other one is still going. Here's one of the images from one of the rovers showing a beautiful Martian landscape. So think about potential places that people might want to colonize Mars. Where would you pick and why? So here's an image from the first rover that landed, the Spirit rover. And what you can see here, these marks are where the spacecraft actually landed. They tested brand new landing device with big balloons that inflated, and then it bounced several times and eventually rolled to a stop. Getting rid of the map at the top, you can see the landscape again. They picked a safe area for the spacecraft to land. And of course, looking for water is important, and we can see why it's important as the rover turned off to the right, and you can see what the water is being used for today on Mars. Starbucks is just everywhere. Well, let's take a look at some of the images. The rovers traveled quite a distance on Mars, and some of the highlights of the discoveries. This image here got everybody excited because this is up close some minerals that precipitated out of water. This particular mineral is called hematite, and they were called blueberries because the very first images that came back, they used false color to show that mineral, and it was blue, so it looked like a bowl of blueberries. Of course, there's no biology here. This just shows there was liquid water. This is an interesting picture, nothing to do but with water, but this is a beautiful iron meteorite that had fallen onto the surface. They got beautiful pictures. This is looking inside of this impact crater. They could look at the crater walls. They get a chance to really do geology, although there's nobody there that can move or manipulate the samples. And this is some of the landscape near one of the big craters on the surface. Looking forward in time, this is the European big mission that went to Mars. This is not a lander, it just stayed in orbit, but it had some spectacular pictures showing where there might be water today. This is in the northern plains, a few impact craters, but if you look at the shapes on here, it looks much like you might think of the Arctic Ocean on Earth when you have the ice break apart and then freeze again and then cover it with dust. So again, suggesting there's a lot of water under the surface. This is a region near the equator that's called a chaos region. And what this is, it's a site of an ancient, gigantic flood. So imagine that there's a whole layer of ice underneath the surface. Something heats the surface, the ice melts, and you have a catastrophic flood that carves out huge canyons. And we see this all over the surface of Mars. Could be an impact created the energy, or it could be volcanoes. But again, evidence of a lot of groundwater on Mars. The spacecraft also had some radar, and they can directly image ice beneath the surface of the planet. Now the next one, the US mission, the Mars Reconnaissance Orbiter, had some spectacular imagery, and it's a little bit hard to see here. These two features are impact craters, but what's inside the craters, and you may or may not see the detail, are flow features. There's actually glaciers buried underneath the dust flowing into the craters, and they're covered up. But again, a lot of ice near the equator today. So there's plenty of resources on Mars. And then finally, Mars Phoenix. This one landed, and I don't have a map here, this landed way up north. This was the one that was going to the North Polar regions to more directly look at water. And they were very surprised. All they had to do was scoop a little bit of the surface off, and there's ice right beneath the surface. If we take a look close up at the Mars Phoenix, this is the arm that scooped up the surface. That's one of its solar panels, so there's where the Phoenix landed. And if you look at the terrain, it doesn't look remarkable, but it looks a bit wavy. And in fact, we see this sort of terrain on Earth, and this gives us a clue that it's ice. In the Arctic regions, where you have ice underneath the dirt that freezes and thaws, you get this sort of humped up terrain. And so that gives us a clue, without chemical sampling, that again, we have ice on Mars. The really exciting one is the current mission, the Mars Science Laboratory. Now, they picked this impact crater named Gale Crater. This was an ancient crater that was filled with a lake, liquid water, 3.8 billion years ago, about the time that life was first developing on Earth. So the hope was the conditions were correct for life to start, and so they wanted to look at this crater to not only understand the habitability, but to see if all the right ingredients were for life. Of course, everybody hopes that you could discover life, but that's not what the mission was about. Then the crater, after it was flooded, had all these sediments and debris in it, and then eventually wind cleared out some of it, and you're left with a big mountain in the middle. And much like on Earth, the Grand Canyon gives you access to billions of years of history. They hope that this crater, too, will give us history of the past environment on Mars. So the spacecraft landed in this flat region, right about in here, and they picked this region hoping that a river material could have flowed into here, and then eventually the rover is going to make its way over to the central mound and start exploring this. So what are they finding? Here's one of the first images. It's a selfie made by the spacecraft. It just took a bunch of pictures with the arm, and then they took the arm out of the picture so you can see what the spacecraft looks like. This is one of the very earliest images. And then they started to bring back the color images, and you can see the central mound in the distance and all the layers, which the geologists are really excited about. Zooming in a little more detail, you can really see the structure on Mars. I love this picture because imagine if you're a colonist on Mars, what it would be like to look back at home. Up here, there's Earth, just a speck of light in the Martian sunset. Looks very alien, doesn't it? So what has the Mars Science Laboratory found? Well, it's not found life, but it's found some pretty exciting stuff. It's found tons of evidence about the water. For example, this rock is fossilized ripples in a lake. You know, when the wind gently blows the water, you get the sand to ripple up. And that's what this is. We can see the layers in the lake. We can measure the chemistry. And what they're finding within the crater, there were lots of different conditions over time that were very suitable for microorganisms to survive. Doesn't mean they were there, but the conditions were correct. They've even found some organic compounds now. The very first missions to Mars found no organics whatsoever, and that surprised everybody. Organics should be everywhere. Mars is near the asteroid belt. Things crash into Mars. The reason there were no organics found with the early Viking mission is that the radiation environment in space is very harsh, and it's very harsh on the surface of Mars. So this will be an issue for colonizing. All right, we've explored what Mars is like, so how does it compare to Earth? Because if we're thinking of colonizing Mars, we want to know how it compares to our home world. And these are some of the things you might like to compare. A little less gravity on Mars, plenty of land area, the day is about the same length, the tilt of the Earth's rotation axis and Mars' rotation is the same, meaning it will have seasons. The atmosphere is very different in composition. We need oxygen. There is no oxygen on Mars. And in fact, the atmospheric pressure is almost non-existent on Mars, and that's going to be a major issue. Because the atmosphere is what primarily protects us from dangerous radiation from space. No magnetic field on Mars, and a lot of people think that also protects us on Earth, which it does, but the primary protection for radiation is the atmosphere. And then we've got certainly a lot of water on Earth, but we have quite a bit of ice on Mars, so maybe it's not so different in that sense. So what are the hazards of having a colony? Well, as I've mentioned several times, the biggest hazard and the biggest difficulty in going into space is not the technology, but it's radiation. We've got high energy radiation in the form of X-rays, gamma rays, ultraviolet. We've got high energy particles flowing from the sun and from deep space. And when these interact with tissue, it destroys bonds, creates cancers. And in fact, most people don't realize it. If we were to somehow get above Earth's atmosphere, close to the Earth, the lethal radiation would be reached in about 2 minutes without protection. So most of this is making its way to the surface of Mars, and one of the missions was actually testing this. Other hazards, low gravity. Astronauts have found when you're in space for any length of time, the lack of gravity is detrimental to your health. And of course, without an atmosphere, we're going to have meteorite impacts on the surface. So our world has this thin veil of gas around it that protects us. So that's a hazard that's going to be significant for colonies. So for Mars, what are we going to have to worry about? We'll have to worry about radiation levels, so we'll need some sort of shielding. That will be the first priority. We will need something to breathe. Mars atmosphere, we can't breathe, but it's useful. There's carbon dioxide, CO2. Maybe with a little energy, we can get some oxygen there. Atmospheric pressure, very low, so you'd have to be in a pressurized suit on the surface. The temperatures are cold, but they're not terribly extreme, similar to Antarctica. Good vacation spot for me, maybe not you guys. Gravity, it's less, 40% of Earth. Maybe it's okay, we don't know. Nothing we can do about it. So, how would we do this? What are some design issues that are important for a colony? Well, it breaks into two areas. The physiological ones, we somehow have to survive there, so we have to meet all of these needs. But there's also the psychological issues for a colony. You're going to be on an alien world, which to me and many would be absolutely exciting. But to others, this means stress. It's a very dangerous environment, so there's risk. So you have to deal with that, and some ways you deal with it are personal space, some entertainment, making it aesthetically pleasing. So what would be some of the steps to having a colony someplace? Well, we have to overcome some transportation issues. We certainly know how to travel in space, but right now the cost is prohibitive. Right now, to send one person to Mars might be $10 billion. A travel time of about 5 months, during which time we don't know how to fix the radiation problem. You need to get this more economical, and that's the venture capitalist Elon Musk is proposing to develop cheap transportation so that you could go for only $500,000 only. On the other hand, if you have too many launches, we destroy Earth's ozone, which is a problem for us on Earth. What are we going to use for shielding? Well, initially, maybe you just use the ship that you came in, but eventually you have to have more than that, so we have to worry about that. And then we have to start getting local resources because of the transportation costs. You cannot bring everything from home. So we need to make sure that we can get many of the materials for the colony from Mars itself. Possible designs. These are several designs that have been proposed by scientists from many places. Some people propose building it underground. Other people proposed vast domed cities, perhaps in lava tubes, or something that will eventually look like modern cities on Earth. Here's Elon Musk's vision of what his Mars colony might look like. I love this quote from him. He said, "I think it would be great to be born on Earth and die on Mars, just hopefully not at the point of impact or landing on the surface." Although it's very interesting, I've been to meetings where someone says, raise your hands if you would be willing to go to Mars, knowing it's a one-way trip and that you may die very quickly after you get there. And many scientists, you'll go to a meeting, it'll be 3/4 of the room will raise their hands. Let me ask you all, how many of you would go to Mars knowing it's a one-way trip and you might only live a few months? Okay, we've got quite a few. Although I do notice it's some of the older folks in the room. So how would we do this? Just some ideas on the early stages, and we'll wrap this up. Some people think you would start to use some of the spacecraft that carry you to the world as your initial shelters as you start setting up things. Things like energy production and so forth. And of course, there's been popular movies that have been made. This is some scenery from The Martian on their first exploration of a manned expedition to Mars. And it looks very much like the space art that the scientists have envisioned for going to Mars. And of course, in The Martian, there were plenty of hazards, if you've seen that movie, with the giant dust storm on the surface. But I think some of the scenery in the movie is absolutely spectacular and really gives you a feel of what Mars would be like as one starts to colonize the world. What's beyond colonization in terms of building structures? Some people have talked about the possibility of terraforming a world. And what this means is completely changing a planet to make it habitable by humans without being in shelters. So some of the things we'd need to do to Mars are obviously we need more atmospheric pressure to give us radiation protection. Some of the ideas people have had is put large orbiting mirrors so you shine sunlight and melt some of the ice, add new gases to the atmosphere to create a strong greenhouse, raising the temperature, put microbes on the planet to use up the CO2, produce oxygen, or start throwing comets and icy bodies at the world to deliver a lot of water and energy. And in fact, people that have studied this say that it might take a few thousand years to eventually get a world that's habitable by humans, but it would be a very costly enterprise. So I think experience shows us that we can deliberately alter a planetary surface. We're doing that to Earth right now, man-made. Creating an unconstrained planetary biosphere elsewhere has not been demonstrated yet. There have been experiments that have failed, such as the Biosphere 2 experiment in Arizona. But we're explorers, and this is our next frontier. And the big question is, are we ready to do a colony on Mars? With that, that concludes the brief introduction. And now I believe we move on to what the activity is for the evening.
Yeah, actually, well, just being an astronomer, I know that there's lots of interesting knowledge actually behind, embedded in each and every PowerPoint pages, what Karen just gave us. There's lots of things to talk about. But I would like to ask the group leaders to come up here. The 每一组的小组长 come up here. 还记得小组长是谁 ？Do you still remember who the group leader is? OK， 好，上来吧。没事 ，you have to comfort him 。要安慰他，他才敢上来吗？大家不要按照顺序随便站，随便站。好，我们问一下，第一组到了没有？第一组，哎，李家维馆长也上来，看到这人挺熟悉的，没有关系。第一组、第二组。第三组、第四组、第五、第六、第七、 第8、第9、第10、第11，你们再错开一点站好不好？不要在那不交换一下位置好了，就像我们洗牌一样好不好？就像当做扑克牌洗一下，这样。OK， 好，可以了哈。好，然后那你弯过来，我们围成一个圆圈，围成一个圆圈。好。然后台湾人叫数枝，大陆叫什么？从0到5，我数到3，出一只手，任何一个数字从0到5，好不好？1、2、3，还好，至少大家都还很理性的，8、10、15、18、22、24、26、28、29，绝大多数出什么？2，他们以为在照相呢。这0、29号，好。放下来，从这边开始，1、2、3、4、5、6、7、8、9、10、11，好，22、23、24、25、26、27、28、29。OK， 从这边开始，你是正方第几组？
我第一组。
好，第一组正方。
第二组。
第二组反方。
第三组。
第三组正方。
第四组。
你移过的又是第4组。
第10组。
第10组。OK。对，组你是哪？第一组正方。
第二组。
第二组反方。
第10组。
第10组正方。工作同仁记一下，好吧？我们有没有工作同仁在记一下？好，要辩论。第一组正方，第二组反方，第10组正方，第5组反方，
第3组正。
第3组正方，第7组反方，11组正方，
第9组。
第9组反方，
第4组正方。
第几组
？4组。
第4组正方。
第6组。
第6组反方。
第8组。
第8组是正方。OK， 好，工作人员记好了顺序没有？顺序记好了没有？再一次好，第一组，第组，第2组，第10组，第5、第3、第7、11、9、4、6、8。OK， 好，我跟大家 I'll announce the rule. Now we split up. Every group find a location, find a place, and work on the upcoming question for 20 minutes. 你们每一组讨论这个题目。如果你是正方或者你是反方 ，discuss and then this issue, controversial issue， 然后决定你们的 opinions and who is going to represent 你们这个 group. Find a person. 我们有3个晚上，3个晚上的代表是要不一样的。上来讲2分钟，2 minutes。OK， 好不好？那现在各组就带开自己找一个可以讨论的地方，开始讨论吧。好 ，OK， 我要 put on this page。中文我稍微解释一下 in English. OK, go ahead. Yeah, if you were the president of a space advanced country, should you begin to plan colonizing Mars? 好了，中文是如果你是一个太空先进国家，不是城市啊，太空先进国家的首领，首领听起来就是 like Trump， 川普，你会计划殖民火星吗？好，有正方，记得哈，这个不是城市，这是先进国家，太空先进国家的首领，那你会计划殖民火星吗？好，把题目记下来以后，各组就带开了。You have 20 minutes， 20分钟以后回到这边，我们开始我们的辩论活动了。Okay, each and every group will send a person up here, and preferably speaking English or bilingually. Send up here for 2 minutes, and we have a staff there will time very rigorously, and a bell will ring at 1:50. 1分50秒的时候，闹铃会响。看你能不能在2分钟之内 finish within 2 minutes. 然后呢 ，a second person is allowed to comment from the same group. 也就是第一组的 from group 1, you have one person up here to state your opinion, and then followed, if anyone prefers in that group, followed by his or her 30-second comments. 可以补充的。OK， 好了，大家准备好了没有？没有。Apparently, okay. Now the question is, if you were the president of a space advanced country, should you begin to plan colonizing Mars? 好，第一组，我们的是第一组上来，第一组的代表是哪一位啊 ？OK， 好，拿着麦克风，等到你开始演讲的时候，我们就开始计时了。走到中间来。好，先讲一下自己是谁，然后哪里来的。
Good evening, ladies and gentlemen. My name is Wang Yuqiao. I'm a fourth-year medical student from Taipei Medical University. And it's a great pleasure to have this opportunity to represent my group. We agree that it is necessary to plan colonizing Mars if we were the president of a space advanced country because, first of all, our resources are running out on Earth, whether we like it or not. The weathers are getting more and more extreme. It's hotter in summer and colder in winter. So we need the resources on Mars. And secondly, politically, if we were to be the first country to colonize in Mars, we could claim perhaps the most proportion of land there. So that's for political reasons. And the reason we choose Mars instead of other planets is because of its distance. It is the closest planet to Earth compared to other planets, Jupiter or Saturn. And also, there's water. There's evidence of water, maybe not in the form of liquid, but gas or solid form of water. And also a thin layer of atmosphere, which we can't get any of that on Moon or anywhere else. And also there's carbon dioxide, which is a very good source of oxygen. So if we were to colonize people there on Mars, we could build a dome, a tent, a glass tent that was in Dr. Meech's presentation, and perhaps a machine that sucks in the carbon dioxide from the atmosphere and creates oxygen that gives us a good environment to live in. And also there's the minerals, irons on Mars, which is essential for industrial constructions. And also the time there in Mars, there's a 24-hour, it's about 24 hours per day, so it's closest to Earth. We wouldn't have to adjust our daily lives due to the differences. And those are the reasons why we believe it is time that we start to plan colonizing on Mars. Thank you.
Okay, thank you. Alrighty, anyone from Group 1 want to make a 30-second comment? 第一组有没有人要做30秒钟的补充的？有没有？好，没有的话，那我们就 move on to the Group 2. By the way, he just said that Mars is the closest planet to Earth, which is not exactly right. Right? No, 火星不是最近的。好。
Hello everyone, I represent the Group 2, and sorry, my English not better than the first one. And we have a few perspectives about the topic, and the first one is the biology perspective, and the second one is economy, and the third one is moral perspective, and the last one is the political perspective. And first one, we think we have to admire one thing is very important. We have to bring a lot of people to Mars because of the population size. If the population size is too small, as somebody has learned some biology, you will know that it will have some problems because of the genetic drift. If the population size is too small, and if so let me see. So, after a few years, some genetic diversity will lose, and loss is diversity, so it will be very dangerous. And the second one is the economy problem. Because of, just like the professor said, one travel from Earth to Mars will cost a lot of money, like 10 billion or more or less. And it will have a lot of economic problems. So we think that if we want to improve the human welfare, we have to put the money to other things, but not the Mars, but not to build a new colonization in Mars. And the last one is, we think is a very important issue, is the political problem. Because just like just like China and Taiwan, if some people if some people from Earth move to Mars, and it will have some problem after maybe many years later. Because if I am the Marsman, I will say, oh, you guys are Earthmen, and I have a higher class than you, and it might be some worse later. It's our group's opinions.
Yeah, OK， 好 ，Thank you。好，第二组 Group 2 ，anyone want to make an additional comment? OK。
I would like to add a point is that our question is, you are president of a space advanced country. You are not a representative of the global, the whole Earth. So you are clarify that the Mars is for your own country only. It's not for the whole Earth. So you will have a big political issues. Thank you.
Yeah, OK, thank you. 好，那 Group 10， 第10组，第3 Group 10。
Hi, I'm Sherry Wang from Group 10, and we're support to colonizing Mars for several reasons. First, because of the political problem that we think we're the pioneer of the whole all over the world. So if we do this, we will be the pioneer. And several other factors will be invited to the environmental part, because we think Earth is overcrowded now. It's about 7 billion people, and I think it will more later on. So we don't have enough food and habitat to live. So that's the reason why we need to colonize in Mars. And also have a lot of environmental problems, including air and water pollutions, and the global warming, because it's too hot. So probably later on we would not have an environment that is appropriate for us to live. And we have a lot of natural disasters, like the typhoon that we just overcome. So if we want to avoid this kind of natural disasters, probably it's a good idea for us to colonize in Mars. And later on, we think that also colonizing Mars can help us to discover new resources, such as minerals and creatures, and we can increase the biodiversity and also a gene pool. And later on, we can also set up for a relay station for other planets, so we can know more about the outer space more. And since we know much in the solar system compared to other systems, so probably Mars is quite similar as in Earth. So probably it's the best place that we can emigrate if we really need to emigrate. And that's the reason why, considering of the oxygen, water, sheltering, food, and energy, we think it's a good idea that we can build a particular region, and that is on the Mars, so it's suitable for us to live. And about the issues that we need to consider, I think the other person would talk about it. Thank you.
I would like to give a brief support. I mean, high risk and high pay, and we're all gamblers in the name of science. Thank you.
OK 好，Group 5， 第5组 Group 5。
I am Meech Yang from Group 5. I'm a food and nutritional sciences student in the Chinese University of Hong Kong. Our group opposed the idea that we would like to colonize Mars if I am the president of the space advancing country, because of 3 aspects. The first one is cost effectiveness. The second one is concerning about the health of the people. The third one is about the demand of the colonization. First, I'll talk about the cost. Because transportation of the resources and infrastructure to Mars costs a lot of money, as mentioned. So we would like to also mention that rebuilding the ecosystem in Mars would be very costly, as the lack of oxygen, the very the radiation from the sun would be hazardous to human health. And we think that even if Earth is facing a lot of pollution and damages or climate change, if we have the ability to rebuild the climate in Mars, we can use the same technology to repair our Earth and conserve the environment. The second one is about human health. During the travel, the UV radiation in this space is very hazardous. And also after we landed in Mars, the bone density would be affected because of the low gravity. The risk of osteoporosis and osteopenia would increase, and then it will also affect our blood circulation due to the low gravity. And also, it is the point of the demand, because a lot of people would like to stay on Earth. I think not so much people would like to migrate to Mars, as professors just mentioned in our survey, because we actually would like to stay on Earth if we are able to repair it. So if we have the ability to repair stuff, if we have the ability to rebuild stuff on Mars, we can have the same technology to rebuild it on Earth, and so we don't need to leave Earth. Thank you.
Okay, great. Anyone from Group 5 wants to add a 30-second comment? Anyone? Okay. 好，下一组 Group 3， 第三组。
Hello everyone, my name is Zian. I'm a chemistry student coming from NTU, Singapore. Okay, so this question is about imagination question. So if I were the president of the space advanced country, right? So it's kind of political question. So if you are president, most of the president will try to expand their land, territory in Earth. So also will do in the Mars. So if I'm president, due to the world population increase rapidly, so I think I will help my people to move there. So I will use the technology to make a Mars become a better world for us to stay. So I think I have quite a different opinion from previous group, but the previous group also state out the reason we are going to move to the Mars. So actually, we are just talking about politics, and that's all.
Okay, thank you. Anyone from Group 3 wants to add a 30-second comment? Okay, Group 7.
Hi, I'm Chen Jianping from Group 7. And now I'm the president of a space advanced country. So I have to care about my my dearest fellow my Gomin. I don't know how to say that in English. And
countryman.
Yeah, countryman. And so the interest of my countrymen is the most important. So first, I have to consider the possibility of bringing back some unknown disease from Mars. Even though there's no known microbe on Mars, but there may be something like prion. Prion is not a kind of microbe, but it is also dangerous. So we have to consider the possibility of bringing back a kind of disease. And also, it will cost too much money to colonize Mars. There are too many problems that are harder to solve than the problem that we have on Earth. So why not solve the problem on Earth if we have the money? Why not spend the money on my countrymen? There are a lot of poor people. We should use that money on them, not to colonize Mars. And also, there's an example of failure of a closed system. Have you heard about Biosphere 2? 生物圈2号. It is an example of a failed closed system. So if we want to colonize Mars, we have to build a closed system on Mars in the initiation stage. And it is very hard for a closed system to live on its own. Even Biosphere 2 on Earth failed, so we think that it is very hard to success on Mars. And that's all of our point. Thank you.
Okay, thank you. So that's group 7. Anyone from group 7 wants to add a comment? Okay, group 11. 11组. Yeah.
Okay, how? I will try my best. Okay, we will agree to begin this plan because we are the space advanced country, so why not? And and the curiosity is the nature of the human beings, and so it's very worth to explore the place where need to be developed. And we also know there are many questions about this place, but there are also some necessary elements like solar energy and carbon dioxide on this planet. So we are agreed to build a greenhouse and bring blue green bring some
blue algae.
Blue green algae and some water to layer to do the previous work. And but the atmosphere is also not enough to prevent the high energy from the solar and the high energy solar winds. So it's better to live beneath underground for us. By the way, we also need to explore the necessary resource on the Mars, like how to change the water from the from the rock. Okay, that's all. Thank you.
Okay, thank you. Yeah, anyone from group 11? 11组有没有要加点 comments 的 ？OK， 好 ，Group 9， 第9组。OK， 好，第9组给他们加油啊 ！OK。
Okay. Hello everyone. I represent my country, 9. Yeah. I'm the president. And I'm going to talking about why should we go on Mars or not. First of all, there are pros and cons, and I want to talk about why do we want to go on Mars. First, we are human. We will go to somewhere we don't know. We will challenge the impossible. So, should we colonize on Mars for this? Like these groups just said, we are scientists and we will challenge impossible, right? Nope. I'm the president. This project is high cost, high risk, and deep profit. Scientists can go on Mars. Let me remind you, explore doesn't mean colony, right? We don't have to live on Mars, just like we don't have to have colonize South Pole, Antarctic, or somewhere else on mountain, right? We can explore there, we can have scientists there, we can do research there, but we don't need to live there. This is the first part. And second, let's talk about risk. The environment in Mars is harsh. The radiation, atmosphere, air pressure, they are all threaten our lives, okay? And then psychological concerns, health concerns. In space, astronauts can get ill for the low gravity and the loneliness. And moreover, on Mars, they are only half of the sunlight of compared to Earth. So with such low sunlight, people will get melancholy and they will maybe commit suicide. On health concern, this is not reasonable. And then unknown virus and unknown bacteria. Although we know there are no living things on Mars, but don't forget, on Mars we have ice. Nothing can be sure in the ice. Maybe ancient virus and bacteria may stay in the ice and kill us.
Okay. Yeah. You talk like President Trump. Yeah. Let's make America great again. But anyway, group 4. Do you want to add 30 seconds comment? Okay. 好。
Well, we didn't agree with Group 10 because by being a president, you don't have to be a gangster. You just have to be humble, humble, and humble.
Well, it's your responsibility to explain to Professor Karen Meech what that means, humble, humble, and humble. Okay, later on, you just try to explain to her, and where does that come from, okay? But anyway, group 4, 第4组. It's very hard to explain humble in Chinese, 谦卑, and also 1,000 glasses of wine. 谦卑. Anyway, try to. 好。第4组. Okay, go ahead.
Hello, everyone. Nowadays, increasing pollution has caused a lot of social issues. Lack of food supplies, pollution, crowded area, and the others. Here I'm there to provide some suggestion in order to prove that our colonization plan is feasible. We can make artificial greenhouse and bring some microorganism to fix the problem of lacking oxygen and carbon dioxide. And we can make artificial gravity to fix the different gravity in Mars. We are explorers, so we should plan colonizing Mars. Thank you.
Okay, thank you. Group 4 is going to, anyone wants to add 30 seconds? Okay, group 6, 第6组.
So hello everyone, I'm a medical student from University of Hong Kong, Year 1, and my name is Kason. So I have a great pleasure to represent my group mates from Group 6. And there's 3 points that I need to make clear about why we have to go against the mission of colonizing Mars. So the first one is whether it's feasible, second one is why, and the third one is whether it's ethical. So the first one is feasibility. So the fact that we can see that in this PowerPoint, we can see that Mars is not a good place to live. And even though how much money that we have, it takes us a long time to do that in order to colonize Mars to make it habitable. That goes back to the cost effectiveness from Group 5, that actually we think that spending so much money on Mars that is not that a habitable space is not a good thing to do. So the second thing is why. So why do we have to colonize Mars? Do we colonize Mars because we destroy the Earth so much that we need to find another place and destroy it after hundreds and thousands of years, and then we move to another place again? So why don't we think about protecting the Earth instead of colonizing Mars? And the third one is ethical issues. If people keep on colonizing Mars and then we go on colonizing other planets, does that mean that we never end the greediness of the human? We humans are selfish species. And then if we go and keep colonizing all the planets on the universe, that's not going to end at all. And going back to the explorer, from some of the groups, such as Group 9, that mentioned we humans are explorers. We should always explore the space that we haven't been before. Yes, I agree. But you have to think about whether the idea of exploring something is actually fairly selfish from human. And instead of exploring somewhere that we haven't been before, why don't we try to protect the space that we have lived for a very long time? And one last thing I want to mention about overpopulation and biodiversity, that people go for the idea of going to colonize Mars. Sorry about that. But anyway, so in order to solve the overpopulation problem, why don't we still put the money to colonize or to develop other spaces on Earth instead of going to colonize a planet that we have never been to? So these are the points that we have made. Thank you.
Okay, thank you. Yeah, both Karen and I were put pressure on on him. That's group 8. I was group 6.
Group 6, yeah.
Group 6. Is anyone from group 6 wanted to add another 30-second comment? No? Okay. Last one, group 8. Oh, microphone.
Good evening, everyone, and we are on the agreed side to colonize on Mars, and I'm from Group 8. And thanks to the hard work of our group members, we have come up with 3 reasons why we should colonize Mars. And first of all, consider we were from a space advanced country, and we have no problem with the science and technology. Because the Mars is located at a suitable position in the solar system with endurable temperature. Therefore, it's more time-saving and cost-saving to colonize Mars. And the second reason is due to the population explosion. As the power of production of food on Earth could not keep up with the geometric growth of human population, Mars can provide spaces for living and crops growing. And therefore, our country can become the pioneer in solving these problems and attracting more stakeholders to provide the funds to solve this problem too. And also, although we have the technology, the resources on Earth are still limited and will eventually be exhausted. There are certain minerals and solid water on Mars, as mentioned by Professor Karen, and it can be the supply of resources for us. As mentioned before, Mars is on the suitable locations, so we can utilize the solar energy to further development and even create a suitable atmosphere on Mars, and providing a more suitable environment for human to live on Mars. And that's our point. That's our points. And thank you.
Okay, thank you. Great. Yeah, okay, anyone from group 8 wants to add another comments? Okay, we're done with our 11 groups. Somehow speaking English makes the whole thing faster. Yeah, if they were talking about it, they were using Mandarin or Chinese, I guess the whole process will drag a lot longer. But anyway, I believe there is certain other opinions that people wanted to express. Anyone wants to add comments from any groups? 有没有人想再加一些意见的 ？Against yourself? No. That's not allowed for the debate. Okay, 好。站起来讲，站起来讲。
Colonizing on Mars is colonizing on a new planet and a new environment. And from this long time, we should know that for this 1,000 years, human has been damaging the Earth's environment. And this is not right to change another environment in another planet. We have destroyed our planet already. We shouldn't destroy another planet now. Yeah, thank you.
Okay, before we move on to the comments from professors, I'd like to mention one interesting event which will happen on Thursday afternoon. I don't know if you still remembered what you saw in the calendar. Thursday afternoon, there will be a interesting competition for finding faults in science movies. And with the help of our great staff, we're going to have basically 3 movies. Not the whole thing. Don't worry that each movie costs you 2 hours and 3 movies 6 hours, you know. No, we'll just show clips by clips, 就是一段一段的 movie 哈. Yeah, just take a wild guess. Which will be the #1 movie? Martian. Yeah, Martian. 火星任务。台湾we call it Martian 火星任务，大陆上叫什么 火星救援 ，Yeah, and China. 台湾叫绝地救援，大陆上叫做火星救援。You know, this translation is pretty interesting. I just want to mention one thing that 我们觉得 the most funniest translation of China on one movie. Remember the movie The Day After Tomorrow? In Taiwan, we translate it as 明天过后。It's very philosophical, you know. 明天过后本来就是 the day after tomorrow. 明天过，你知道大陆的同胞 I asked our Chinese friends, why do you call it 后天? I said, why? And they said, the day after tomorrow is 后天. Well, the day after tomorrow means where will you be after tomorrow? 它有它的 philosophical meaning in it. 但大陆就直白的把它翻成后天。我说，如果他要再拍一个 sequel 续集，叫什么？大后天。Okay, but anyway, the first movie will be Martian, and the second one, I guess, our staffs are working on it. The second and third movie will be Armageddon and Deep Impact. Yeah, both are related with the alien object hitting the Earth, comet or asteroid hitting the Earth. So that'll be 3 interesting movies, but we'll not show the whole thing, only show the clips and paragraphs which has scientific problems in it. Okay, now I guess the comments and the opinions from all these 11 groups may be summarized into several questions. We can give questions to Karen for her to reply or to address this question. I guess people were asking one simple question: is it going to happen one day that our Earth is inhabitable in the future and we just have to leave? Okay, that's one interesting question.
The rate we're going, yes, and it may be sooner rather than later. I've got some colleagues at the University of Hawaii who think we have already gone beyond the point of no return on global warming. And you know, so many of you said, why not just fix Earth? If we have the technology, let's go to Mars. But in part, you could reverse that statement by going to Mars, by investing in the technology, you might be able to solve problems faster on Earth. And you know, many of you mentioned, let's fix things, but one thing that could occur we cannot fix, and that would be if there's a nuclear war, the radiation will last too long. So, you know, for some of you that said we shouldn't go because we can just fix things, I'm not so sure about that.
Okay. I'm just giving questions to Karen, but anyone wants to add your comments or questions, you're very welcome. Okay, another one is that traveling from Earth to Mars, in my impression, takes about 8 months, but you were mentioning 5 months. But I guess it's anywhere between 6 months to 11 months. Psychologically and physically, what kind of threats we are facing? Do you want to address that again?
Well, many people say, of course, there's huge risk in going. And there's always problems with being in space for that long, with isolation, depression, the normal things you'd see when, in fact, you're in prison.
But people say that when they have a cell phone, so no problem. You can play games.
Well, no, the light travel time will mean you don't have instant communication. But I think people overwhelmingly agree the excitement of going to a new world might prevent some of these problems. But you would have real physical problems. One is the 0G, and in fact, if you're traveling to Mars for that many months, you can exercise to keep the muscles fit. You will experience some bone mass loss, but they've shown that you can pretty much function, but you're not going to be at peak fitness when you get to Mars. The big one is radiation. That's why we haven't done it yet, and that's solving the radiation problem. We know how to do it. You just need 1.3 meters of lead shielding surrounding you, and that's adequate protection. That's a lot of mass. That's really expensive. And so they don't know how to do it economically. And it doesn't have to be lead. It can be anything. You could have ice, but then you need more material. If it's ice, you'd need something like 10 meters. So some designs of spacecraft said, well, maybe you put the fuel tanks surrounding the habitats so that you have the protection from radiation. But I don't know about you, I don't think I'd want to travel inside of a fuel tank for 6 to 11 months. That sounds pretty hazardous. So there's some issues to work out.
Okay, let me try to explain in Chinese. 他刚讲了2件事情，一个是骨质疏松，骨质你的 bone mass 的 loss， 骨质疏松；另外一个是你要防护那些有害辐射。第一个骨质疏松，大家知道在太空里面 weightless 的环境底下，无重量骨质疏松有多厉害吗？一般在地球上面，对于一个70岁的女孩子的骨质疏松比较严重。70岁的老的女士，每一年会 lose 1% 的 bone mass。骨质疏松每一年损失 1%， 对于一个健康的年轻的 astronaut， 在无重状态底下，每个月损失 1%。如果你不运动的话 ，so for 8 months， 那是很可怕的事情，你的 bone mass loss。那另外一个有害辐射 ，Karen 说了，你一旦离开了地球的 atmospheric protection 大气的保护的话，那你需要有1.2米，大概1.2米的铅 lead，remember that chemical element。1.2米的铅才能够防护有害辐射，哎，这不是单一方向的，你要把自己用1.2米的铅包裹起来，你觉得那个太空船会有多重？那我今天下午我们在讨论时 ，I was talking about the ice because you have lots of ice on Mars。但是呢，如果你要做一个冰屋的话，那个铅的密度，你跟水的跟冰的密度比较，你需要有10米的冰块。10米的冰块防护你才能够防护太空中的有害辐射。那刚刚 Karen 讲了，有一个可能是，反正你要带燃料嘛，你就把燃料围绕着你绑起来，但是没有人愿意活在一堆燃料中间，飞到火星去。你可以想象8个月，如果你没有保护的话，那些 harmful radiation 对你会有什么样的影响 ？Yeah, that's.
I had a question for the students. You may have brought it up. I couldn't tell. How many of you, with a show of hands, would rather have, say, 10 centimeters of shielding, which is not quite enough, or no shielding? So how many would rather have no shielding?
Yeah, 他在问一个问题是说，你到底你会希望有10公分的铅保护你，即使那不够，1米才够，你希望有10公分铅保护你，还是说完全不要保护？希望有10公分的铅，至少有10公分铅保护你的，请举手。
So this is no shielding or 10 centimeters?
10 centimeters.
All right, so 10 centimeters?
那 no shielding 不希望有任何保护的，就如果你没有就不希望了。Okay, this is no shielding.
I'm traveling with the no shielding people. 10 centimeters is more dangerous than no shielding at all. Because the high energy radiation hits the shielding, splinters apart atoms that are also going at high velocities. They emit gamma radiation, X-rays, ultraviolet. Those particles hit more material in the shielding, so you get a shower of radioactive material. What you need is enough to stop the entire shower. So if you can't have enough shielding, you're better off without it. But for 9 months, you're dead either way. So.
大家听懂他的意思吗？如果你只有10 centimeter 10公分的 shielding 的话，高能量的粒子打进来的话，撞击那一刹那就会产生非常高能量的 gamma rays、X-rays 跟 UV， 然后呢，撞击出来的这些辐射会再撞击第2层的原子，你就会一层一层，在粒子物理上面就叫做 shower， 不是真的去洗澡，而是那一层 secondary 跟 tertiary showers， 那其实对人的影响是更糟糕的。所以他说，干脆就不要防护。还稍微好一点，但他如果不要防护跟10公分，8个月下来反正是死路一条。
I wanted to point out something. Many of you talked about those that supported the colonies, something like this. That's a problem because it's not enough shielding in the glass. So psychologically, unfortunately, we're probably looking at underground or in a lava tube because glass won't work.
So actually, Matt Damon in Martian, his environment is lethal, right?
Yeah.
Okay, well, I'll leave that to Thursday.
Same with Elon Musk. His city isn't going to work either.
Yeah. 大家知道他的意思吗？I think in Chinese translation, 他说 会很棒。如果你是生在地球，然后死在火星，生在地球死在火星一定很高兴，因为你是个探险家。但是你不希望在着陆那一刹那就死。了解吗？ That's the whole idea. So you don't want to die instantly when you arrive in Mars, right?
Yeah, but in that kind of shelter, he's going to die fast.
他就说这个会死更快一点。Okay, I guess people talked about is it what in the 60s President Kennedy raised the issue that we should go to Mars or go to the moon. It's not because it's easy, it's because it's
Difficult,
hard.
yeah.
It's hard. 但是 you know what? Kennedy's wish made the technological effort put together to achieve the success of landing the moon. So is it another, leading ideas just to point it to that we should go to Mars, and then all these technology will come by?
I think so. Politically, that stimulated the economy, it stimulated science, and it was done for political reasons to make us number one in technology because they were afraid of space technology from the Russians. So it was not for science that the US went to the moon, it was military, effectively. But it gave us a whole world of technology that we wouldn't have had otherwise.
Okay. And Karen mentioned that Viking, I guess it's Viking, scoop the soil and then add things to it, nutrients to it, and to see if it will grow, if there's anything, life forms within the soil. 大家知道吗？维京人1号、维京人2号把泥土弄了以后，摆在自己太空船的肚子里面，在火星表面，然后加上水啊、营养剂啊什么的，看它会不会有东西长出来。结果没有。There's not even very primitive life forms in that experiment, right?
No, there was nothing detected. Many of you mentioned that you were worried about possibility of contamination from life forms on Mars, but I pose to you that you may in fact be Martians. It's actually very easy to get material from Mars to Earth. When a meteor hits Mars, because of the low gravity, it can knock rocks to Earth. We have samples of them on Earth. If there was life on Mars early, it could have brought it to Earth. And so you could be evolved Martians. So it may not be that it's dangerous, maybe.
But if there are indeed life forms on Mars, I guess a student didn't address that, right? 大家没有提到说，如果火星上后来发现有生物的话，我们要怎么办 ？Maybe 地球人良心发现说，我们就形成一个保护区、保留区，然后把他们赶进去就好了。No, like preservation area.
I mean, that was one of the ethical issues that I worry about. Do you have a right not to just destroy the environment, but possibly destroy life that's already there? NASA, at least, and I presume other space agencies, have policies called planetary protection. And if you go to an object that has any potential for life, everything must be sterilized before it goes there.
所有东西需要彻底清洁消毒才能够去 Mars. Yeah. That's for landing device, right? The orbiting spacecraft usually do not go through that.
No, that's not true. For example, the mission to Jupiter's moon Europa. Europa is a small moon that is outgassing vapors, water, and it has organics, so it has all the ingredients for life. There's a liquid ocean, and so anything that goes in orbit around Europa must also obey planetary protection because the radiation environment is so harsh at Jupiter. By the way, not a good place to go for that reason. It destroys electronics, and so things can crash. And if it could crash, they have to be sure it's protected because you don't want to crash on Europa.
大家听得懂吗？木星的第二个卫星木卫2叫做 Europa。Europa 其实是一个美丽的仙女 ，It's a beautiful lady Europa。但是台湾名字翻成欧罗巴，听起来好像欧罗。But anyway, Europa 已经看到它有冰喷泉、水喷泉喷出来了，然后有包含有机物在里面，所以 Europa 在它的冰冻表面底下有咸水海洋，那有 一切生命应该存在的条件。所以即使是 mission 飞到 Europa 旁边不降落，在旁边绕，也要彻底清洁。为什么？因为木星的 radiation 太强，木星的辐射太强，会破坏那个太空船上面电子零件。这太空船非常有可能会 crash 在 Europa 表面。那你如果上面带了地球的微生物，掉上去以后，过一阵子你再去看，上面已经有生物存在，搞不好还讲英文，所以就 ，yeah。Well, just telling them that if it's not thoroughly sterilized and then dropped on the Europa surface, for a number of years later, you will find life forms on it. That's probably from Earth and speaking English. Okay.
We crashed a mission, the Galileo mission, as it was starting to fail. They had to decide what to do with it. And so they purposely crashed it into Jupiter's atmosphere. They couldn't just let it fly around in space because it could potentially come to Earth. And so some people said that wasn't sterilized. Why did you crash it into Jupiter? First, we don't think there's life on Jupiter. And the second reason was we already crashed something into Jupiter, so we've polluted it already.
大家知道1995年的那个 Galileo 太空船最后的命运就是 crash into the Jupiter， 撞到木星的大气层里面去，因为木星比其他卫星来的更没有机会有生命的。Yeah, Jupiter, Galileo for Jupiter, Magellan for Venus. 麦哲伦号撞到金星上面去 ，and the one now circulating Saturn, Cassini, will eventually crash into Saturn, September 15th. Yeah. 所以 you know what? You may think that all these scientists in NASA is full of violence in their heart, try to terminate missions by just crashing them into the planet, but actually the real reason is to avoid contamination. Is that right? Yeah. 所以是避免污染，不要污染一些有可能有生命的环境。Okay. Well, I'm so glad that actually Karen prepared all these issues, but after our discussion, Karen decided to leave this page after your debate because we want to see if students will bring up these issues, which are important issues. Do you want to briefly talk about?
One thing I wanted to mention, and part of it was with private conversations at dinner, if we've destroyed Earth and we have to go to Mars, we don't have the technology or capability to bring everyone. So who gets to go? The rich people that can pay? No, I think you bring the people that have some function, that have the skills. Who decides this?
Rich people do not have functions.
Some may, but you need to be able to fix things. You need to have multiple skills and be flexible. So that's a big issue. Ethically, who gets to go? If the world is ending, who would you pick? If it's 1 out of every 100,000, 1 out of a million, is it a lottery? Who gets to go? Who owns space? Who has a right to claim Mars? Is it just the first person to get there?
But Karen, there's a real estate company in the United States. It sells the land on Mars.
And you bought some?
Yeah.
I'll sell you some.
Yeah. 有人在美国还真的就是开个公司开始卖火星上的土地，还真的有人买。
I'll sell you some.
Yeah, so what?
I'll sell you a good piece.
Oh, okay.
So these are some of the issues that I thought about, and the cost would be enormous, but if we face extinction on Earth, does it matter what the cost is? So I think you guys did a great job, and I wrote down some notes on comments for what you had said, but I think we've covered everything, so I liked all of your points.
Okay, great. Yeah.
About how do we pay? Isn't there an enormous entertainment value in this? So it could be paid for, like, you know, we want to see reality shows and slightly crazy things like Formula One racing and so on. Enormous sums could go into the entertainment of having some people going to Mars, and then we could hope for spin-off effects, like everyone who advocates for Formula One racing say we get a lot out of that, and you just said that the moon program has had a good spin-off. So let the people who likes entertainment pay.
That's a good idea, but I think if we were truly talking about a colony, and someone made an excellent point about you need a large enough group for genetic diversity. So we're talking a lot of people. I think we don't know the costs, but I think it's a large fraction of the world's gross national economic product for many years. So it's a lot of money, and I don't know, well, maybe the entertainment industry has that kind of money.
到火星上面去创造实境秀啊，或者是 Formula One 的赛车啊什么的，用这种方式带人过去。But I guess student brought up one thing which is quite enlightening, is the Biosphere 2, the failure of Biosphere 2.
Well, I mentioned it's a failure, but it's just a failure in terms of they had to cheat. They had to bring in some oxygen. This was supposed to be a closed experiment for 2 years. The oxygen levels dropped very low. They had to let in air, and then some people got sick and they had to take them out to treat them. I don't consider that really a failure. It was a marvelous experiment, and if you don't do that simple experiment, how do you know how to do it on Mars? And so this was a learning activity, and I think the big thing that they learned was it wasn't enough diversity. They didn't have enough plants, and it wasn't big enough. I think a real colony has to be enormous so that a single point failure doesn't mean a disaster.
大家知道在 Arizona 那个 Biosphere 2的 program 吗？那我先问大家，哪一个是 Biosphere 1？ The Earth, yes. 为什么那个计划叫 Biosphere 2？ 就是因为地球是 Biosphere 1， 生物圈1号是地球，但那个计划到后来并没有成功。But there were only like 8 people in there. The second time they entered the dome is 8 people.
8, 4 men, 4 women.
Yeah. But, you know, so the oxygen level drops. But I guess they don't get along well, is that right?
Some of them didn't, some of them did.
所以其实是很困难的，不是只有科学技术的问题。Okay.
Well, the oxygen level dropped, they discovered later, they made a foundation of cement. And cement has to cure, has to dry for a long period of time because it sucks in oxygen. And it turns out they didn't let it cure long enough. So they learned a valuable lesson for when you build a colony.
Yeah, 所以 Biosphere 2用混凝土啊什么的，把太多的氧气吸走了，所以学到很深刻的教训。但是Karen 说的，这并不是一个真正的失败，所以还是可以讨论一下。But 有没有are there any other comments? Okay, 听听您。
Yeah, I'm a little bit tired. I don't feel well, so I just say a few words before I go. First, I'd like to thank Karen. Wonderful introductions, and particularly at the end, your explanation. I really learned a lot. Yeah. Well, today we have 2 groups of students, positive and negative. I was impressed by all your English. Very good. But the answer, no matter positive or negative, are very similar. Well, Karen told us that it's inheritable. High radiation, no oxygen, right? Why we go there? Okay. Well, the answer is simple. We want to be the first country to colonize there, right? I love my people, so I want to bring my people there. That's for the future. That's the answer. But that really didn't solve the problem. For people who don't want to go, I remember the best answer. Humble, humble, and humble.
Second time, Karen, you heard about it.
You know, I think people from Taiwan are familiar with that phrases. I understand it's not easy. I don't expect the student will have perfect answers or really nice answers. It's very difficult. What I really thinking is that, has anyone think about how to overcome this problem? No matter whether realistic or unrealistic. I think that you should think about. Right? Radiation, no oxygen, and all this difficult environment. Well, I'm a biologist. Do you know in biology, there are bacteria, for some reason, survive in high radiation. Their bacteria survive in very high temperature, very cold temperature. They evolve mutations. We may think about that. That may give us some clue. If they can survive, maybe that's a way we can think about how to change the genes. And if we can do that, maybe someday we can go there with all these technologies. Right? Yeah. That's what I've been thinking. Otherwise, just said that, oh, we go there, we overcome all the difficulties. How? You have to have some more practical ways. All right, I don't want to say too much. For those who don't want to go, I understand. I met the student there. I said, do you want to go? No. Why? Too much uncertainties. I understand, right? Who want to go to some place you don't know what to do. Yeah. But today, one student said a word which impressed me. We are on the earth. Why we want to move out? Because earth has a lot of problem. We have to solve that problem. Overpopulation, fuel, food. Do you think those are unsolvable? I'm not too certain. Maybe we can solve it. At least to some degree. If we can do that, why you have to force all these lovely people to go to Mars was inheritable. That's in my mind. This is my personal opinion. I just raised this and let's all think about it. Okay. Thank you very much.
Yeah, thank you.
Something you said really resonated, especially with what you brought up with Kennedy's speech. We do it not because it's easy, but because it's difficult. And many of you asked at lunch and at dinner, what makes a good career? What makes it interesting? Why should I go into this or that science? And I said, do it because it's difficult. That's where it's satisfying. That's where you're solving mysteries. Don't do it because it's easy.
Yeah, and I want to bring up one thing that Chinese used to say, 安土重迁. You know, 安土重迁 means usually people don't want to move because they get so accustomed to the original place. And you observe the same effect on your campus. You know, I experienced a few times that my department has constructed a new building. And who is going to move into the new building? Half of the faculty would, the other half wouldn't. 就知道一半人可以搬到新机去，一半人不愿意搬。For those half who is more adventurous, they move into the new building and enjoy the new environment. But for the other half who decided to stay in the old building, they are also happy because half of people are gone. So they have even more spacious place to stay. But I guess if it becomes inevitable, this is something that we really want to think about, who gets to go, right? But you want to add something more to it?
No, I think it's an important issue, and it could be worth thinking about and discussing during the workshop.
Okay. Yeah. 好，那李定国教授刚刚有 Professor Lee.
Yeah, I was wondering about the radiation issue. I assume it is not worse than the International Space Station. So why in the space station we know there's some astronaut for 1 year staying there. So what exactly is the problem here now?
Well, the space station, they stay up for a year, but these are considered high-risk workers. You wouldn't send pregnant women up to the space station. It's like a nuclear power plant worker. They have accepted the risk of increased cancer. So for ordinary people that want to live on Mars, these are unacceptably high risks, and it's going to be a lifetime. So that's the difference. It's the time of exposure.
Yeah, but then maybe you can go 1 year and come back and, So I'm just wondering, what is the real problem here? It's the money.
Well, yeah, we know how to mitigate radiation, just enough shielding, and that's a matter of mass, which is a matter of money.
I guess the effect is not short term. You don't see anything bad happen to the astronaut right after they come back to the Earth. But NASA does carry out such an experiment. For example, there are 2 twin astronauts, Scott Kelly and Mark Kelly. They were twins, both 51 years old last year. And Mark Kelly, I guess, retired from NASA, but Scott Kelly gets to go to the station again. But even Mark was monitored every day, along with twin brothers on the space station, monitored every day, just to compare what would happen for the person up there on the space station compared to his twin brothers on the Earth. I guess that's one way to see the difference.
And there's two types of danger. One is from deep space, and that's constant, but it's like a slow rain. The other is from solar storms, and that is immediate, within the light travel time, and extremely severe, and for that, you have to have a radiation shelter. But that can be small. The problem is you can't live in small for months.
I mean, that comes to who want to go to Mars. I mean, the previous question, the question is many scientists want to go. But if you take, say, to be the 1 year, then it probably, many people want to go and come back. I certainly would like to go if for 1 year. Whether I will get this radiation, I don't care for my age. That was not an issue. If you want to go forever, then that's different. So I think that's a little bit different. Now, if one takes, you can get there 1 year, even radiation won't kill you right away. That's a different story.
Yeah, Professor Lee will use his sabbatical from Academia Sinica 休假的时候. But I guess it's a one-way trip, because once you go over to Mars and stay there for several months, get yourself used to Martian environment, I guess it's even more difficult to come back to Earth.
Yeah. Someone mentioned they would deal with artificial gravity in the colony. That's not possible on Mars. The gravity is what you have. You can simulate a gravitational-like force if you have a colony free-floating in space, and you do that through rotation. And that gives you the equivalent force of gravity. But on Mars, there's nothing you can do about it. You just have lower gravity.
Yeah, 大家知道你在太空里面你可以做个旋转，产生人造的模拟重力，但到火星表面的话，你没有办法一天到晚再旋转了。火星表面的重力是多少？大家知道火星表面跟地球是多少比多少吧？Yeah, 38比100. 也就是 if you weigh 100 kilograms on the Earth, then over there you only 38 kilograms. Yeah, 38 to 100. 所以会轻很多，所以你要回到地球上是受不了的。Yeah, too bad. It's just one-way trip. You don't get to come back. But Elon Musk, 大家知道这个马斯克哈，said I guess a few days ago because we have this telecommunication interview. Elon Musk said sooner or later there will be people going out there experience death. 他说你会看到有人在月球或者火星表面体验死亡了 ，because it never happened before, right? During a mission, people didn't die, but sooner or later it will happen.
Yeah.
所以那才是真实的情况，大家会面对的真实情况。Yeah. OK， 其他的老师 ，is any more comments from 陈耀成老师有没有？彭老师啊，要不要？下。OK， 那个。彭董事长要不要加入讲几句话关于火星的？友达要不要在火星上面设一个厂啊？OK， 好，杨老师有没有想 ？OK， 好，我们有没有人 miss 掉任何老师在现场的？有没有同学们有没有再要提一些问题的？我觉得 Karen 真的是很帮忙，可以提供好，谢谢。Yeah, Karen 很帮忙，因为她真的是非常 knowledgeable。但是 in the next few days you will plenty of chance to interact with Karen, get more information on these issues. 好，有没有其他的要加入的？你要问吗？可以啊，你可以问啊，用中文还是英文 ？Stella wants to ask a question.
I'm wondering, actually everybody, I want to ask a question of, how about if there's any life on Mars? And they agree of the colonization
of Earth, human, yeah.
Yeah, well, kind of. But they have the deal if we have to agree that Mars have to be the capital of the universe. Will you agree of that?
如果火星上有生物，然后他对你说：“我同意你殖民，但是我们要当宇宙的首都。”你会同意吗？同意的可以举手吗？
不知道，好像在搞一中一台啊。No, just kidding. Don't worry, we'll talk about this later. Okay, great. Karen, do you want to conclude?
I have one question. Is the Mars has any fresh that one can, the question about practical issue. You mentioned a little bit, but I didn't get, are there special minerals or anything that can be valuable?
We don't know. Many of the valuable minerals on Earth are deep below the surface, and we've not ever dug below the surface. There's many valuable things that we can get, not on Mars, but in the asteroids. Yes, many asteroids heat up early in the solar system. Radioactive materials in the center causes them to melt, and so the heavy metals sink to the core. And then later on, they get smashed into pieces. So there are some asteroids out there that are just pure metallic cores. If you brought one of those, a small one, a kilometer-sized object to Earth, that would be more gold, silver, and platinum group metals than we have accessible on Earth. And for that reason, it may not be done, because industry on Earth doesn't want that much material brought back.
大家听得懂他讲的这个是很重要另外一个 issue 了，就是刚刚李教授讲说火星表面有没有值得开发的东西，但是 Karen 说了，其实在很多小行星上面是有非常多的贵重金属的，因为如果小行星比较大，它本身的 radioactive 同位素加热会让内部融化，融化以后的重元素沉到中间去，但是呢背后以后被撞了以后碎片出来，有些就是完完全全的是贵重金属的小行星。So this asteroid mining has been talked about a lot. 最近很多公司开始了做 space mining 太空采矿，干什么呢？发射一个太空船去 shoot off the net 射出去一个网子，把那小行星抓了 put over back to lunar orbit for example 放到月球旁边去。 想要贵重金属就去采一块下来。但他说，不见得地球上的贵重金属公司愿意这种事情发生，因为当你把超过全球的黄金跟白银都带回来的话，地球上整个经济市场就垮掉了。但是there are so much valuable metals out there and asteroid 在小行星的。But I want to mention one last thing is 去火星 maybe going to Mars may be less dangerous than stay in Earth's orbit. It's just because the space debris, the garbage out there.
Yes, that's a danger, but I think more dangerous is Earth orbit. We've got the Van Allen radiation belts, which traps high energy electrons near the Earth, so the radiation is actually quite high near the Earth.
But I was watching a videotape on back and forth on the airplane, talking about the space debris as things getting worse and worse. For those things bigger than a baseball, 比棒球大一点的。I guess United Air Force is tracking like 22,000 pieces.
Probably more than that, yeah.
Yeah, but less than that, because smaller than baseball, but bigger than a ping pong ball, they cannot track, but those are still lethal. It's more than 100 million probably. Yeah, 所以那些是真的危险的东西。Now, that's something else that we should talk about later. It's full of danger out there. But anyway, well, we'll give a round of applause to Karen. Thanks her very much.